Alright, so today we're going to attempt to do the integral of ln x dx. And just some quick background before we try to solve this problem. You're going to need to know u substitution and integration by parts. If you haven't learned those yet, then go read up on those and then come back when you're ready. So from previous knowledge, we know what the derivative of ln x is. We know that d dx ln x is just going to be 1 over x. And we know that the integral of 1 over x dx is going to result in ln x plus c. But we don't know what the integral of ln x is. So that's what we're going to go ahead and do today. So I'm going to leave this up here for reference. So the first thing we're going to need to do is we're going to need to make a u substitution. So I'm going to let u equal ln x. And if that's the case, then our du is going to be the derivative of ln x, which is just 1 over x dx. Now I can solve for dx by moving this x to the left. So I have x du equals dx. And notice how this left side is not all in u form because we still have an x here. So what we can do is, going back to our original u equation, we can solve for x by using an exponential transformation. So we know that this is the same thing as saying that e to the u equals x. This is just one of our exponent properties. So if we substitute this x back into here, we see that e to the u du is going to be equal to our dx. Now we can go ahead and make the u substitution. So we have the integral of our ln x now turns into our u. That's this formula right there. So this is the integral of u, and our dx is now this right here. So our dx is going to be e to the u du. Now we're going to need to do some integration by parts to get this integral solved. So we know from integration by parts that the integral of u dv equals uv minus the integral of v du. So I'm going to let u equal to just u. Then our du is going to be equal to du. So this doesn't really change anything. Our dv is going to be equal to e to the u du. So when we integrate that to get v, we're just going to get e to the u itself, because the derivative of e to the u is just e to the u, and the integral of e to the u is just e to the u. So this is just going to be e to the u. Now I'm going to use the integration by parts formula to substitute in. So we know that by integration by parts, this is going to be equal to u times v. So our u stays the same, so we still have a u. U times v, our v is now e to the u, minus the integral of v du. So our v is going to be e to the u, and our du is just du. So now we've changed the integral of ln x to u e to the u minus the integral of e to the u du. Now, this is a pretty simple integral to integrate, because we know that the derivative of e to the u is just itself, and the same thing backwards, the integral of e to the u is just itself. So this is going to be equal to, I'll use it black. So this is going to be equal to u e to the u minus the integral of e to the u is just itself, so e to the u, and we have our plus c. Now we have to make everything in terms of x. So going back to our black color, our u, back from our u substitution, is ln x. So this is going to be ln x times e to the ln x minus e to the ln x plus c. Now we know from our exponent properties that e to the ln x is going to cancel out and just form x. So we can say that ln x times x minus x plus c is the integral of ln x dx. So written a little bit more nicely, x ln x minus x plus c is our